Section 700.12 D2 of the National Electrical Code, or NEC, requires that standby emergency generators be located in a separate building or in a room that is separated from other occupancies by fire-resistant construction. NFPA 110 Section 7.2 states that emergency generators shall be located in a separate room or in a separate fire-rated enclosure within the building. Based on these code requirements, a 45 kW standby emergency generator for life safety emergency egress lighting in the supermarket application cannot be located in the same room as the distribution gear. The generator must be located in a separate room that is separated from the distribution gear by fire-resistant construction. Plans calling for the generator and automatic transfer switch, or ATS, to be located in a room that does not have the main service entrance gear but does have the rest of the distribution gear, do not meet the requirements of NEC 700 and NFPA 110. The generator must be relocated to a separate fire-rated room. Fire-resistant construction, as required by NEC 700.12 D2, refers to construction assembly that has been tested and listed in accordance with recognized standards such as ASTM E119 or UL 263, and is capable of resisting the spread of fire for a specified period of time. The required fire resistance rating, typically expressed in IRs, depends on the specific application and the requirements of the local building code. The purpose of fire-resistant construction is to contain a fire within a specific area, preventing it from spreading to other parts of the building and potentially endangering occupants or causing damage to equipment and infrastructure. Common methods of achieving fire-resistant construction include using fire-rated walls, floors, and ceilings constructed of materials such as concrete, masonry, or gypsum board. These materials are designed to withstand high temperatures and prevent the passage of flames and smoke for the specified fire resistance rating. In addition to the construction materials themselves, other factors such as the proper installation of fire-stopping materials and the sealant of penetrations in fire-rated assemblies are also critical for maintaining the effectiveness of the fire-resistant construction. The automatic transfer switch, or ATS, is a critical component of an emergency power system that automatically transfers the electrical load from the normal power source to the emergency power source, such as a generator, in the event of a power outage. The ATS continuously monitors the voltage and frequency of the normal power source, and if it detects a failure or significant deviation from the normal parameters, it initiates the transfer process. The transfer process typically involves disconnecting the load from the normal power source and connecting it to the emergency power source within a specified time frame, usually within seconds. This ensures a seamless transition and minimizes disruption to critical operations and equipment. ATS come in various configurations and ratings depending on the specific application and the requirements of the emergency power system. They can be manually operated, automatically operated, or a combination of both. Automatic transfer switches are commonly used in a wide range of applications, including hospitals, data centers, industrial facilities, and commercial buildings, where reliable and uninterrupted power supply is essential for safety and business continuity. The National Fire Protection Association, or NFPA, is a global non-profit organization that develops and publishes codes and standards related to fire safety and electrical safety. NFPA standards are widely adopted and enforced by authorities having jurisdiction, or ODs, in the United States and around the world. NFPA standards cover a wide range of topics, including fire protection systems, electrical installations, and hazardous materials. The NFPA 70 National Electrical Code, or NEC, is the most widely adopted electrical code in the United States. It provides comprehensive requirements for the safe installation of electrical wiring and equipment. NFPA 110 is the standard for emergency and standby power systems. It provides requirements for the performance, installation, and maintenance of emergency and standby power systems. Compliance with NFPA standards is essential for ensuring the safety of people and property from fire and electrical hazards. The authority having jurisdiction, or OJ, is the governmental agency or organization that has the legal authority to enforce codes and standards in a particular jurisdiction. The AHJ may be a local, state, or federal agency depending on the specific application and the applicable laws and regulations. The AHJ is responsible for reviewing building plans, inspecting electrical installations, and issuing permits to ensure compliance with the applicable codes and standards. The AHJ also has the authority to issue fines or other penalties for violations of the codes and standards. It is important to consult with the AHJ in the design process to ensure that the proposed installation meets all applicable requirements. Fire-rated enclosures, as required by NFPA 110 Section 7.2, are specifically designed to protect emergency generators from fire hazards and ensure their continued operation during a fire event. These enclosures are constructed of fire-resistant materials such as concrete, masonry, or steel, and are designed to withstand high temperatures and prevent the passage of flames and smoke for a specified period of time. The fire resistance rating of the enclosure, typically expressed in IRs, depends on the specific application and the requirements of the local building code. Fire-rated enclosures also include features such as fire-rated doors, windows, and ventilation systems to maintain the integrity of the enclosure during a fire. The purpose of a fire-rated enclosure is to provide a safe and protected environment for the emergency generator, allowing it to continue to supply power to critical loads during a fire event. This is essential for ensuring the safety of building occupants and the continued operation of critical equipment and systems. In addition to the fire resistance rating and construction materials, other factors such as the proper installation of fire-stopping materials and the sealing of penetrations in the enclosure are also critical for maintaining its effectiveness. When considering the location of a standby emergency generator, several factors must be taken into account to ensure compliance with applicable codes and standards, as well as the safe and reliable operation of the generator. Firstly, the generator must be located in a well-ventilated area to prevent the accumulation of exhaust fumes and to provide adequate cooling for the engine. Secondly, the generator must be located in a secure area to prevent unauthorized access and vandalism. Thirdly, the generator must be located away from flammable materials and other hazards. Fourthly, the generator must be located in an area that is accessible for maintenance and repair. Fifthly, the generator must be located in an area that minimizes noise pollution to surrounding properties. Sixthly, the generator must be located in an area that meets the requirements of the local building code and the authority having jurisdiction. In addition to these general considerations, the specific requirements of NEC 700 and NFPA 110 must also be taken into account, as discussed previously. The National Electrical Code, or NEC, is a set of standards and guidelines for the safe installation of electrical wiring and equipment in the United States. It is published by the National Fire Protection Association, or NFPA, and is updated every 3 years. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. Compliance with the NEC is essential for ensuring the safety of people and property from electrical hazards. The NEC is adopted and enforced by state and local governments throughout the United States. The NEC is not a law itself, but it is often incorporated into state and local building codes, making it a legal requirement. The NEC is a comprehensive document that contains thousands of pages of detailed requirements. It is important for electrical contractors and other professionals working with electricity to be familiar with the NEC and to follow its requirements carefully. The NEC is constantly evolving to keep pace with new technologies and changing safety standards. The NEC is an essential tool for ensuring the safe and reliable use of electricity. The Life Safety Emergency Egress Lighting System is a critical component of a building's fire protection system. This system provides illumination to exit routes such as corridors, stairwells, and exit doors in the event of a power outage or other emergency. The Life Safety Emergency Egress Lighting System is designed to provide sufficient illumination to allow building occupants to safely evacuate the building. The system typically consists of emergency lighting units, exit signs, and a backup power source such as a generator or battery system. The emergency lighting units are designed to automatically turn on when the normal power supply is interrupted. The exit signs are designed to clearly identify the exit routes. The backup power source is designed to provide power to the emergency lighting units and exit signs for a specified period of time, typically 90 minutes or more. The life safety emergency egress lighting system is required by building codes in most jurisdictions. The system must be designed, installed, and maintained in accordance with applicable codes and standards. The life safety emergency egress lighting system is an essential element of a building's fire protection system. It helps to ensure the safety of building occupants in the event of an emergency. Distribution gear refers to the electrical equipment used to distribute electrical power from a source, such as a utility substation or a generator, to various loads within a building or facility. Distribution gear typically includes switchboards, panel boards, transformers, and other components that are used to control, protect, and distribute electrical power. Switchboards are large panels that contain switches, circuit breakers, and other devices used to control and protect electrical circuits. Panel boards are smaller panels that distribute power to individual circuits within a building. Transformers are used to step up or step down voltage levels to match the requirements of different loads. Distribution gear is an essential part of any electrical system. It ensures that electrical power is delivered safely and reliably to all of the loads within a building or facility. Distribution gear must be properly designed, installed, and maintained to ensure its safe and reliable operation. The term separate room, as used in NEC 700 and NFPA 110, refers to a room that is physically separated from other areas of the building by walls, floors, and ceilings. The separate room must be constructed of fire-resistant materials and must have a fire-rated door. The separate room is intended to protect the emergency generator from fire and other hazards. The separate room must be large enough to accommodate the generator and all of its associated equipment. The separate room must be well ventilated to prevent the accumulation of exhaust fumes. The separate room must be located in an area that is accessible for maintenance and repair. The term fire-rated, as used in NEC 700 and NFPA 110, refers to materials and assemblies that have been tested and listed by recognized testing laboratory, such as Underwriters Laboratories, or all, to determine their ability to resist the spread of fire for a specified period of time. The fire resistance rating is expressed in IRs, such as 1 IR, 2 IRs, or 3 IRs. The fire resistance rating indicates the amount of time that the material or assembly can withstand a fire without allowing the passage of flames or excessive heat. Fire-rated materials and assemblies are used in the construction of fire-resistant walls, floors, ceilings, and doors. Fire-rated materials and assemblies are an essential part of a building's fire protection system. The term standby emergency generator refers to a generator that is used to provide backup power to a building or facility in the event of a power outage. The standby emergency generator is typically powered by diesel fuel, natural gas, or propane. The standby emergency generator is designed to automatically start up when the normal power supply is interrupted. The standby emergency generator provides power to critical loads such as life safety systems, emergency lighting, and medical equipment. The standby emergency generator is an essential part of a building's emergency power system. The term supermarket application refers to the use of a standby emergency generator in a supermarket. Supermarkets require a reliable source of backup power to maintain critical operations during a power outage. Critical operations in a supermarket include lighting, refrigeration, and point-of-sale systems. A power outage can result in significant losses for a supermarket, including spoilage of food and loss of sales. A standby emergency generator can help to prevent these losses by providing backup power to the supermarket during a power outage. The NEC 700 and NFPA 110 requirements for generator location are intended to ensure the safety of building occupants and to protect the generator from fire and other hazards. These requirements must be carefully considered when designing and installing a standby emergency generator in a supermarket or any other type of building. Compliance with these requirements is essential for ensuring the safe and reliable operation of the generator.